Hello. So today I'm going to show you guys how to complete arrays left rotation. So if you just want the answer, look at the comment description and there's going to be a link to my GitHub page and you'll be able to download or just copy and paste the code. And I have some comments there, pretty straightforward. If you want to learn how to solve the problem or how I did it, just keep watching the video. So the problem is a left rotation operation on an array shifts each of the array's elements 1 unit to the left. For example, if 2 left rotations are performed on array 1, 2, 3, 4, 5, then the array would become 3, 4, 5, 1, 2. Note that the lowest index item moves to the highest index in a rotation. This is called a circular array. Okay, so now I'm going to show you guys how to actually solve this. So first off, the way I started it is I actually used paper and pen. But once I solved it, I'm going to teach you guys it using a notepad. So notice if we don't shift the array any times, we end up with 1, 2, 3, 4, 5. And then if we shift it one time, we get 2, 3, 4, 5, 1. And on the second shift, we end up with 3, 4, 5, 1, 2. On our third shift, we get 4, 5, 1, 2, 3. And on our fourth shift, we get 5, 4, 3, 2, 1. And in the sample input and sample output of the problem, we have the number 5, which denotes the number of elements in the array. And we have 4, the number of times that we want to shift the array. And then our sample input is 1, 2, 3, 4, 5. And notice that our sample output is 5, 4, 5, 1, 2, 3, 4. And in our notepad right here, when we do the 4 shift, we get 5, 4, 3, 2, 1. Okay? Pretty straightforward, right? So now, say we just keep on going with the shifts, right? Say we have to shift this 14 times. So on paper and pen, what we would do is we would continue going. So on our fifth shift, we end up with 1, 2, 3, 4, 5. On our sixth shift, we end up with 2, 3, 4, 5, 1. On our seventh shift, we end up with 3, 4, 5, 1, 2. Eighth shift, 4, 5, 1, 2, 3. And ninth shift, 5, 4, 3, 2, 1. And then once we get to the 10th shift, it repeats again. So if you guys can notice the pattern here, if we wanted to shift something 10 times, in reality, we wouldn't have to shift it at all, right? And say we had to shift something 14 times. Well, we could just shift it 4 times and we would end up with the same answer, right? So now I want to show you guys about the modulo. When we see a pattern like this, usually we use the modulo. So the number 5 here represents the number of elements in the array, and then 4 represents the number of shifts that we're going to do. So when we calculate this, we have a remainder of 4. So if I go into my notepad and I go into the 4 shift row, I should get the right answer. And notice I will 5, 4, 3, 2, 1. So now say we wanted to shift this 14 times. If you're lost, just keep paying attention. It'll make sense a little bit later. And notice that our remainder is still 4 when we perform this operation. So what that means is that if I shift this 14 times, I could go to row 4 or shift 4 and I should get the same result. And we notice that if we shift this 14 times, we would get 5, 4, 3, 2, 1. But if we just shift it 4 times, we end up with the same answer. So I'm going to do one more example here. So say we want to shift this 12 times. You notice that our remainder is 2. So if I go to shift 2 should be the same as shift 12. Notice that shift 2 is 3, 4, 5, 1, 2. And then shift 12 is 3, 4, 5, 1, 2. So in reality, we don't have to shift this 12 times. We can just shift this 2 times. And we'll have our answer. Okay? So what we're going to do is, now we're going to get to the code right here. So what we're going to do is we're going to create a new list. And we're just going to be putting our integers into it. Instead of reordering the original list, we're just going to be creating a new list, and putting our integers in it because it's quicker. So the first thing we're going to do is we're going to find out how many rotations we need. So D stands for the number of rotations that your user wants to do, and A, that size, is the size of our array. So let's run through the sample, right? So the sample has 4 shifts with an element size of 5. So basically we're going to do this again, and we get a remainder of 4. And our starting index is going to be whatever this equals right here. Okay. So now why did I do that? So let me explain this step right here. So when we do 4 modulo 5, notice that when we look at the original array, at let's see, so 0. So below this array right here, I'm putting the indexes. These are the indexes right here. Okay. So 1 is at index 0, 2 is at index 1, 3 is at index 2, 4 is at index 3, 5 is at index 4. So when we did this operation, 4 modulo 5, we end up with the remainder of 4. And if we look at index 4, we see that we get the number 5. Now, when we do perform the 4 shift operation, we notice that index 4 ends up being the first element in the list. Okay. Now, let me give you another example. Let's do shift 7 right here. So we're going to do 7 modulo 5, and our remainder is 2. So this 2 is going to be our starting index. So when we go into our original array and we go to index 2, we see that the number 3, and notice that 3 is the first number in the array. Okay. Likewise, say we do 6 shifts, and notice that we get the number 1. And notice that index 1 is 2, and the starting number for 6 shift is 2. Okay, so this basically gives us the shift that we want, right? And it also gives us the starting index of our array. Another way to look at it, so look, on 2 shift we get 3, on 3 shift we have 4, on 4 shift we have the last index, which would be 5. If that doesn't make sense, just leave a comment in the section, I'll help you out. Okay, so now that we have that, so we have our rotation, right? So we have the column that we need, right, from line 31. Now line 34, we have our starting index. So again, for the example, we reshift this 4 times, and we have an array 1, 2, 3, 4, 5. The starting number is going to be number 5. Okay, and that's the first thing we do. We put the first number. Okay, so this one on the first iteration, the number 5 is going to be in it. All right, so now what we're going to do is get the starting index all the way to the end of the list. So when we do the 4 shift, the number is going to go, so the iteration is going to go 5, and then we reach the end of the list. So now let's look at the for loop. Our iterator I is going to start at 5 plus index 4 plus 1. Okay, and it's going to keep on going until it reaches the end of the list. In our case, this wouldn't hit. This wouldn't hit because we are starting integer I will be bigger than the array size. And to put that to perspective, let me put a comment here. So I at the very beginning is going to be equal to starting index, which is going to be 4. Okay, because this right here is going to give us, this is going to be 4 mod 5, and that's going to give us 4. And then our starting index here is going to be 4. Okay. So the first number we're going to be putting into our list is going to be the number 4. Okay. Actually, not going to be number 4. It's going to be number 5. Yeah. So 5 is the fourth. Is in the 4th index of the array. Just get that straight. So our i's is going to be 4, but then we're going to add 1 to it because we want it. Because we already have the first elements. That's why we're adding 1. We're not gonna like restart it. So I is going to be equal to I plus 4, meaning that means that I is going to be 5, and that is not less than the size of our array. Our size of our array is 5, so this would be no. So this wouldn't hit at all. And then on the next iteration, what's going to happen is we're basically going to start from 0, and we're going to be placing our numbers all the way to our starting index. So how is that going to look like? So in short, our array starts at 5, right? That's what we did. So our array has number 5 in it. We're going to skip this for loop. This for loop is not going to hit because we already reached the end of the array, and it's just going to restart at 1. So int I is going to be equal to 0. So at index 0 we have the number 1. At index 1 we have the number 2. At index so 0. At index 0 we have the number 1. And at index 1 we have the number 2. And at index 3 we have 3. Right? 0. No, sorry. Index 0 is 1. Index 1 is 2. And index 2 is 3. And then at index 3 we have the number 4. Okay? So I hope you guys saw how I got that. And then when we run the code, of course we're going to be good. I already ran this. But notice how that works. So so if you're good, you could just stop the video here, but I'm going to explain this one right here and how it works. So it might be a little bit easier visualizing this. So here what we would do is we would do 10 modulo 20. So that's what we'll do here. This is our starting index, which would be at index 10. So if we physically just look at this, so 0, index 0 is 41, index 1 is 73, so I'm going to count it 0, 1, 2, 3, 4, 6, 7, 8, 9, 10. So this would be our starting index. So if we follow my algorithm, 77 would be put into the array. That would be the first thing we do. So we already have we already did our modulo, right? We did that here. We saw that remainder is 10. So our starting index would be right here. And that would be the number 77 that I showed. So now what we're going to do is we're going to add 77 to the beginning of the list. And now we might go through this for loop or we might not, right? Depending on the condition. So we put 77 here, and we know that it's not at the end of the list. So if it was at the end of the list, then we would just go on to the second for loop. But since it's not, what we're going to do is we're going to copy all this. And then once we get to the end of the list, so look. So we copied the whole list all the way to the end of the list. And then the second loop basically just copies the rest of it. Okay? So that's basically what these for loops do. This for loop counts. It copies the elements in the list starting from the starting index all the way to the end of the list. And once it hits the end of the list, this second for loop will copy the rest of the items from the beginning of the list all the way to starting index. If you have any questions, just leave them in the comment section.